I'm Miguel. I'm based in Frankfurt. I do risk management consultancy. And today I'm going to talk about a bit tools that we are currently not using in the field of risk management, but maybe, and I'm making the case that maybe we should use them. So, as I said, I'm currently doing risk management consulting. I'm also doing a part-time MSc. So, if any in the audience likes network models, I find them really cool, and I'd like to talk about them as well. And I'm a tinkerer. I like to try out new things and see how they play out. And this is from this tinkering. That's where this talk is coming from. My background is a bit more technical. I did some BI. For a trading platform, and I have a PhD in robotics, speech from robotics. The company that I currently work for is based on 3 pillars. So lots of mathematicians, lots of physicists, so we know a bit about the quantitative side, and we then specialize in the integration of the quantitative side in the IT, and playing around with the needs of our clients, and these needs are very, very related to processes and regulation and governance. So let me start with a story. This is a true story. This company had 2 risk systems, and they wanted to try to figure out whether combining the results from these systems would lead to a reduction of risk and of costs. These systems were specialized. One was for the IRS part, so interest rate swaps, and the other one was dealing mainly with fixed income, so listed versus OTC. And the setup of this story is there had been a huge effort in implementing a software. They had been specified, had been analyzed in a small scale. And the question now is, now the software is ready, does it really deliver what it promises? So we have 2 near productive systems that we had to combine with each other and configure and try to figure out whether the outcome is actually as expected. So we started by identifying large fixed income portfolios. This was in an Oracle database. Then we computed the sensitivity to interest rate changes, the DV01. This was done in Excel. Then we went to the other side and gathered some standard trades, got their DV01s, and then combined these in Excel in order to get standardized trades that we could use in order to set up the systems. Then I realized that I had to generate some XML, so I emailed some files to my laptop. I generated XML files. I then uploaded them individually on the trading system. Then we got some results. So we had 2 trading systems. We had some risk results. They were in an Oracle database. We copied them to Excel. We evaluated the results, and then in the end, you have some basis for a management decision in PowerPoint. So this was a one-off, but it's not very far away from the challenges that you face when you're dealing with these kinds of models. And it kind of boils down to a set of things. So risk management is hard, not because the models are really, really complicated, but because each of the parameters of the models is very complex. So there's a lot of special cases. So think about calendars and day counting conventions. And then in the institutions or in the systems that these figures are being computed, these are systems that are being applied productively. So they're not really flexible. And they're not meant to communicate with each other, because this institution will have a lot of different systems. So data is spread. And if you want to analyze this data in a non-productive way, then you have to be really flexible, and you have to make a lot of assumptions on how you do the computations, because there's no way that you're going to be able, as with your Excel sheets or whatever, that you're going to compete with a productive system. So you have to make simplifications. And in the end, most decisions are only based on these simplifications. So there's lots of sides to this. So I think this is a shortcoming. There's lots of sides to this, and one of the sides is software, in my opinion. So could we have better tools? So what were the concrete problems? So we have the classic problem of no separation of business logic and data. So this is a problem that you have in the most common software, Excel. You have different data sources not meant to communicate with each other. You have, and this is true, this is, for example, if you think about the Python community, there's no scikit finance or something. There's a lack of out-of-the-box functionality and easy to integrate. And in the end, because you have all of these, then you have some other symptoms, which are you cannot reproduce most of the workflows or most of the analysis that you will be doing. And these are often coupled with very large efforts. So in the end, you're actually paid to make very good educated guesses on, given the goal of your analysis, to figure out the best way with your limited resources to get the answer to the question. And it's 2015, right? Why do we still have these problems? This happened last year, so I was then thinking about, why is this so? And in my mental map, there are main reasons behind people using the tools and the software that they're using. So the first one is the software is available. This seems like a no-brainer, but it's related to the deployment problem. So this is a real challenge. The second one is functionality. Can the tool, even if approximately, deliver compute the things that I wanted to compute? And then there's a social part. So can I collaborate with my colleagues? Can I give them intermediate results?
Is the mic working? It seems to be.
Yeah.
Can you try to get a bit closer, because people in the back can't hear?
Okay, sorry. So can you collaborate with your colleagues? So can I give you intermediate results, and will they be able to continue with the work that you've been doing? And in the end, if you have done some results, you have to share them. And will the people be able to use the results that you have been producing? And then I looked into obviously there's other parts to software. But given the current PyData ecosystem tool, and I'm biased to Python, and that's the reason why I came to PyData, but I think that there are very interesting tools coming up. And I think that they have a place maybe in a risk management setup to address the four main reasons that I've mentioned. So you have the availability might be solved by, so you have Anaconda as a distribution, you have Jupyter with the notebook that everyone is using. You have Blaze, that I find very interesting to transfer data around. You have Bokeh to show the results. And you have Pandas, and Pandas delivers you a set of functionality that is very, very interesting. So again, availability would be covered by Anaconda, the functionality by Pandas, and a bit by Blaze with aggregations and transfers. Collaboration with Jupyter, you would be delivering your notebooks and letting people continue. And then sharing your results again with Jupyter notebooks, and then making some nice plots with Bokeh. So this was the setup. This was the map that I've made to the reasons to the existing tools, and I wanted to explore this. And I wanted to do an example, and yes, so I thought of starting with the lowest common denominator of risk models, which is value at risk. So value at risk is a very popular measure, right? Because it's in addition to that, it's very simple to get your head around, and very easy to communicate. And it gives you kind of a boundary to the losses within a given certain confidence interval for your portfolio, for a set of assets, and a given time horizon. Now, from a regulatory point of view, there's a mathematical definition to this, and from the regulatory point of view, this is also very, very interesting because this is one of the standard models that has to be used by financial institutions. So I went and implemented this model in a way that I could tinker a bit with this model and produce some nice plots. So I extracted some risk factors, and by the way, the notebooks are available online, and you might want to play around with them. And I'm just looking at data. I'm just extracting data with Blaze. And then I will be doing something that is called the filtered historical simulation, where you look at your time series, compute the returns, and then try to project the returns in the future, so your asset price changes in the future, in a way that you abstract from the market conditions at the point in time where you measure them. So you're filtering out the volatility and trying to get a good estimate on how severe your losses in the future could be. So I have a model. I implemented the model, and now I want to play around with the parameters to this model. So I've built some interactive plotting with Bokeh that is using both Blaze and both Pandas functionality. And in order to do this, I have a set of data, and I have to build something that is called the column data source. And this is what this function is doing. So I'm building the column data source. I'm building a dictionary that is being just a placeholder for some variables. And then I have to build two functions. One that updates my model and is doing a very important thing, which is pushing your data, the data that you have updated with the new parameters of your model back to the notebook, so back to your plot. So it's going to be updating the plot. Oh, this one is live. So in order to do the plot, this is actually very simple. You build a figure object and then add different glyphs to this figure object. And here I'm building two plots that I will show you now. So these are the two plots, just showing my the volatility, my log returns, and then the green line is the devolatilized log returns. So for this filtered historical simulation, there's one main parameter to this, and this is well, depending on how you estimate the volatility, it's the lambda. The lambda is determining how reactive you are to changes in the volatility. And now I can go around, and I hope this works, and change the parameters of my model. I can go to the standard configuration, which is 0.94, and you see the volatility line, so the orange line updating accordingly to my new model. So this is a very nice way of, if you have to communicate some decisions or some analysis that you've made, you can not only deliver some static plots, and simply only by programming Python and building a widget, then you can actually give someone something that they can play around with. And this turns out that this is a very much more efficient way of communicating. So now that I've extracted my features, I want to build a predictive model. And this predictive model is just projecting the devolatilized returns into the future using my current volatility. So this is what this is doing. And again, in my model, in my implementation, which is just a couple of lines, this sums up to these two function calls. Now that you have built some predictions, you have to look at how good your model is. So and usually in order to do this, you do the backtesting. So you go to a given period of time and you confront the predictions that your model has delivered with the reality. There are standard ways of doing this. There's the Kupiec proportional failures test. And like everything in finance, every result has to be mapped into 3 colors. Green, yellow, and red. So that's basic language of communication. So I'm doing something similar as I done with a simpler plot. I'm doing making a pipeline of computation in order to update my model. Then I'm generating the column data source, so the Bokeh object that I can upload and feed to my plot. And then the plot creation. I have 2 plots that I initialize. And I have then to update the plots accordingly. So what I now have here is using the functionality from the IPython widget, again, a possibility of playing around with the models that I have and seeing how many outliers I have. And you can see that it is very significant to the choice of lambda parameter that I have. And that whilst the models are actually very simple, the consequences of configuring a model differently, they're very severe. So when I did this for the first time, I wanted to do this also, and I mentioned that I like to tinker with new stuff. I wanted to do some stuff with Spark, and when I said that I wanted to do some stuff with Spark, my main focus was actually in the performance. So taking the existing functionality that you have, so like aggregating large chunks of data and trying to beat Oracle databases for this. And I had kind of an epiphany, and I think that this is the technology that is interesting, much more interesting for other reasons. And I'm going to go to these reasons very, very soon. In any case, the reasons are, the first one is the scope, right? With the current tools that you have, and even staying with the PyData ecosystem, with the tools that I've shown, you have the possibility of doing analysis on a much broader scope of assets portfolios. So you can stay with simplifications on your model, but you can improve your analysis by increasing the data that you have at your disposal. You can also use the available tools in order to, especially with Blaze, in order to span the gap between different data sources and different systems and minimize, for example, ETL processes and processes that run overnight and take very long to run. And then when you've overcome these difficulties, maybe you start thinking about, maybe you've guaranteed your survival, and then maybe you start thinking about different use cases that you haven't had the time to think about. And although they are currently being implemented, they're very costly in time in terms of effort. So one of the things is having like an aggregated view on the risk across the whole enterprise. So you might have different companies within the group, and maybe you want to have an aggregated view on this. And the other thing is, maybe you want to build scenarios that you can really explore because you didn't have the computing power to do this. And as you have spanned over different systems, you might want to change, for example, like macroeconomic variables and see how would my company do, or how would my financial institution do if there was a break in the GDP or a pandemic situation. Doing stress testing in a much more realistic way, that would be one of the outcomes. So I would be spanning, for example, market risk, credit risk, liquidity risk, and trying to bring these figures together in a meaningful way. So this is something where technology can help. Obviously, there are different reasons why this is not being done so often nowadays. There's governance issues, there's cooperation issues, there's simply also the complexity of doing the risk measurements. But maybe technology can help here. And Spark, I think, is something that is providing a glimmer of hope that we can do this. That technology is not an obstacle anymore. Because, for example, VaR risk is very easy to simplify. So it's a relatively simple model. It's very easy to parallelize. And so it will be perfect, for example, for MapReduce. But the models are not that simple. So Spark gives you a bit more than MapReduce. And it gives you a programming interface where you can abstract from the data size to a given complexity, and gives you, for example, something that is very important in the financial system, which is, or for financial industry workers, which is support for SQL. It also lets you use two programming languages that are very common with people that know statistics, like, for example, R, and is at this point in time evolving and enjoying widespread adoption. For example, IBM has endorsed Spark as their computing engine of choice for the future. So Spark is actually an ecosystem of tools, and in the end, what they're doing is trying to bring these tools together with common APIs. And this is very, 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 very promising. So I wanted to evaluate whether you could actually bring Spark to a financial context. And I wanted to evaluate this from the point of view of computational complexity. So complexity description. So in a sense, would I be able to program a Spark job if I only have 2 days in order to do this, and different other problems to tackle? So how descriptive, how powerful is the Spark, what Spark is currently offering? So I have a very small toy example here. And what I tried to do was to take the results from the previous model that I've shown, the previous implementation, and try to aggregate them. So just very, very, very simple toy example with very little data. And let me go just briefly through it. So what we have produced with the other model, and we had then evaluated, is we have a set of scenarios per day, for example, per risk factor. And we want to aggregate these scenarios in order to get one view for one day. the first thing that I have to do is parse the data source that I have. And I wanted to do this in this way, saying that a risk factor scenario is a risk factor ID, a date, a value for my neutral scenario, and then an array containing scenarios. This is where I started having some trouble with Spark's limitations, because aggregation, for example, of results is currently something that is supported only with a very limited set of functions. So there is no custom aggregation of results, so there's no user-defined aggregation functions. So I changed my data representation, and the data is in this format. So you have the risk factor, you have the date, you have the neutral scenario, and then you have a set of scenarios. And I had to build the type in a programmatic manner. So this is how I do it. So this was the first quirk that I had with the framework. Then I have to define a parsing function, because the function is the input. Spark is going to read this as a line of text, and I have to transform the line of text into something that is structured. And then after this beginning, the nice part starts. So I'm just programming Python here. I'm reading the text. I'm parsing it. And then I am creating a data frame, which is a familiar object, especially if you know Pandas. The data frame doesn't have a very human-friendly appearance, and this is the first line, but it is in a way that I can aggregate it. So I can group by date and do the sum of all other columns, and Spark figures out which columns it can add and which ones it can't. For example, it will not add the risk factor ID. Then I will map each of these groups with a lambda function, and I'm extracting the risk factor ID, the date, and then I'm doing my valid risk calculation. In the end, I pack this into a Spark data frame again, because this was an RDD, and then I get my figures. So it took me a time to get through it, but it's fairly easy to understand once you've seen it. So it's nothing compared to what was like doing MapReduce jobs 5 years ago. Then I try a slightly more complicated case. So I'm defining a portfolio, which consists of a risk factor ID, a quantity, and a portfolio ID. And I'm going to do the same exercise. And now the first thing that I do is I have to join the scenarios with my portfolio definition. And this is also fairly easy to do. The aggregation is a bit more complicated. But the group by operator is very easy to work with. So in the end, through a very similar pipeline, I can get the results. So in the end, after doing this, I have a very good feeling about Spark. It really gives you a way of abstracting from data sources. So I could simply get an RDD from a text file, or get an RDD from a database. You can do JDBC connections, or simply get an RDD to S3 or Hive, and then work with it without being aware that these differences exist. So this is very, very important, because I'm not shuffling my data around in order to do my jobs. Because in the beginning, currently, if I want to do something complicated, I have to get my data copied explicitly into the same data source. So if I have two different databases, I have to find a way of copying data from one database to the other database, and then do the join work. So Spark is giving this possibility of abstracting. And then it's giving you some programming objects that are very familiar. So it's giving you a data frame. It's giving you a possibility of querying these data frames using SQL. And for me, these are very powerful constructs that Spark delivers. And I wouldn't be very surprised if it delivers on what it promises. That being said, there's a wish list that I have that would really help me convincing other people in the financial industry that Spark is the way to go. The first one is being able to custom aggregation, to define custom aggregations. That can also work with a SQL functionality. The second one is bringing more functionality into the Python R world, because most of it is currently inside Java and Scala environments, which are closer to the JVM where Spark lives. And a very large problem is that currently it's difficult to get around problems with memory. And there are no recipes or not clear ways to tackle these problems. And finally, we need more examples. So we need to show people how to do stuff. When I start tinkering with Spark, I could only find examples of word counts. So everywhere I looked, there was word count here, word count there. So this is not really helpful. And so I decided to contribute a bit and give this talk and maybe launching the idea and maybe giving you the idea that Spark is the way to go. And I would like to finish with a quote from Freeman Dyson. That new directions in science are launched by new tools much more often than by new concepts. This effect of a concept-driven revolution is to explain old things in new ways. The effect of a tool-driven revolution is to discover new things that have to be explained. And that was my contribution. Thank you.
Thank you, Miguel. Questions for Miguel? Amit.
You mentioned you have the notebooks up.
Yeah.
Is there an address?
Yeah, sure.
We will certainly be, besides that, we'll also be aggregating all the speaker talks onto some sort of Git repository. So
there.
Oh,
did you guys have this view the whole time?
Yes. Do you need to have something to adapt?
No, I was wondering whether, I just realized
Oh,
that.
sorry, it's because sometimes the screen is flipped, so you're presenting on your screen there, and that's showing you the presenter view for whatever reason.
Ah.
You can see you can see the whole thing. It's fine, Miguel.
Okay. That's the first.
Just a quick question. I saw you were using Python 3 with
Yep.
Spark 1.4.
Yep.
It's enabled?
Yeah.
Okay.
Yeah.
You try to use Spark with R?
No, I don't like R. It's an important use case. I will try it sometime, but.
Just following on that, is there a particular reason you use Python 3.4 rather than say 2.7?
Unicode is one reason for other projects, and the other reason it's being developed actively at the moment, and I didn't have any problem when. So Ian Oswald was the reason I switched, and I didn't have any problems, and so I'm sticking with it.
Unicode is a major problem.
Yeah.
That's gonna make Ian very, very happy.
Okay.
I constantly have to tease him about his zealotry towards moving people towards Python 3.4. But that's a big win if it's him alone that has pushed you towards it. But the official line at PyData is that everyone should be using Python 3.4. Yeah, so it's great.
Yeah.
It's just great to be seeing it being chosen. Anyone else questions for Miguel?
I saw you have a small section where you define PDFs for Spark, but those are lambda functions. So is it possible to define something for
Yeah. Yeah, but not for aggregation, as far as I could get from the documentation. So
say if I have a function that has dependency on other modules, would that be possible?
Yeah, you probably have to set up each environment where you're running your Spark jobs, but that is possible. Yeah.
And last question, if anyone wants to ask one. Lovely.
Have you considered using Flink instead of Spark?
No. What is Flink?
It's a European equivalent which doesn't have a static topology that can have the out-of-memory exceptions that you have in Spark.
Okay. And how does it work from the let's say from the complexity?
Functionally it's equivalent, but I think it's probably easy not behind from a technology perspective.
Okay, but could you explain? Could you let one non-tech savvy user work with it? Okay.
No, chat later if you want.
So that's my biggest. That's the source of my biggest interest in Spark. That people that don't necessarily know the inner workings of an RDD can actually do something with it. So this is for me a very, very, very important issue.
Yeah. Right. Well, thank you very much, Miguel.